Okay, let's sketch the diagram for this problem. We've got a hot end at 80 degrees C. We've got a cold end down here at 30 degrees C. We've got metal bar. This part up the top is formed of gold. This part down the bottom is formed of silver. We're asked what's the temperature here at the junction between them. And we can look up in our table and see that the thermal conductivity of gold is 314 watts per meter per degree C, and that the thermal conductivity for silver is 427 watts per meter per degree C. Now, the most important point for answering this question is that it says it ends up reaching thermal equilibrium. So that tells us that the power transferred through the gold must be the same as the power transferred through the silver. If this was not the same, it would suggest that somewhere in the middle we're either having the energy collecting or the energy being depleted, which would mean that it would get very hot or very cold in the middle here. And that's not what happens as it reaches thermal equilibrium. So we know that the power flow through the gold is equal to the power flow through the silver. Now all we need to do is substitute into our equations. So we've got P is equal to Ka, change in temperature over the, well, in this case the length. We can say that these have length L if we want. They have the same length. Okay, so for gold, we've got K for gold times the surface area of the gold times the change in temperature. So this ends at 80 degrees C. This ends at Tj. And then over the length, and that's the same for the silver, Kag, A. And now the hot end is at temperature Tj, the junction temperature, and the cold end's at 30 degrees C. And that is over L. So the L's and the A's will cancel out as they're common factors. So we can put all the TJ's onto the left-hand side and all the numbers on the right-hand side. Okay, so let's substitute in. We've got 314 TJ. And then over this side, let's move this over. So plus 427 TJ is equal to 314 times 80 plus 427 times 30. Okay, so now we can just solve for Tj. 314 times 80 plus 427 times 30 over 314 plus 427. Solving that on the calculator, we end up with 51.2 degrees C.